there's another one.
Guys, if you would, please get out paper and a pencil, okay? And if you take notes today, I'll give you 10 points. We've got to get this radicals. No, I want you to please work on what I gave you yesterday, okay? And actually, please work on it. We have to get this down by next week because finals are next week and we're running out of time.
I don't know you were ready.
What?
Oh, I have recording?
Don't be indifferent. I'm not gonna show it. No, don't. Just for my big hand.
My voice is going to be
Hey Jose, you got a calculator on you, right?
Yeah, well I have my phone.
Yeah, I might ask you for a little help because my phone is being used. And I gave all the calculators to Scott for TCAP.
Okay. Do you have to take notes?
Yeah.
Yeah, please. I have to jump. I have to jump.
Yeah, good job. You can handle it though, I know.
Yeah.
It was in the track.
All right, so Destiny.
Yeah.
What is the square root of 1? What times itself equals 1?
1.
Yeah, so the square root of 1 is
1.
1. Okay, so what's the square root of 4? What times itself equals 4?
2.
2. So it has an even square root. What's the square root of 9?
3.
Okay, 3. But what's the square root of, say, 3?
What?
What's the square root of 3?
1? No, 3.
1.5.
You're thinking of 3 divided by 2.
Square root of 3.
What times itself equals 3? I don't even know, and I'm a math teacher. I don't know.
So you can't do it.
Yeah, well, you can, but you need a calculator to do it, okay? That's why we just leave it in this form sometimes. If you have a square root of 4, then just make it 2. But this we don't know. It's going to be a big, messy number, and Jose's about to tell us what it
3
is.
is 1.7.
1.7? But you're rounding, right?
Oh no. It's 1.7, 3, 2, 0, 5, 0, 8, 0, 7, 6.
I think I got that right. If it's a little off, it's okay. And it keeps going on and on because you only have a certain amount of number of places that your calculator can hold. So, when dealing with the square root of 3, we just call it the square root of 3. But this makes sense that 1.7 is between 1 and 2. Guys, Lori, thank you. It makes sense. Square root of 3. Okay, 1 and 4. 3 is between 1 and 4. So the square root of 1 is 1. The square root of 4 is 2. So it makes sense that the square root of 3 is between 1 and 2. It's 1.7. So when talking about the square root of 3, we just call it the square root of 3. We don't call it 1.723508076.
So just leave it like that?
So we just want to refer to it. We just want to call it this. Okay, that's why these special right triangles are getting a little weird, because we're not really breaking it down all the way. We're kind of leaving it like this. So Jose, what's the square root of 2? First of all, what do you think the square root of 2 is going to be in between once we solve it? It's probably going to be between 1 and 1.7 and all that.
1.4, 1, 4, 2, 1, 3, 5, 6, 2, 4.
2, 4, and it's going to go on and on, okay? So that's why we just call it the square root of 2. We don't call it 1.4142135624. Okay, we have better things to do, so we just leave it as square root of 2. All right? So now when talking about these special right triangles, does anyone remember what the two special right triangles are? One's a full. Okay, that's the second one. That's a slightly more complicated one. What's the other one? 45, 90. And the other one is, what were you saying, Lorenzo?
60, 40.
Close. 30, 60, 90. So if this is 45 and this is 45, and that's our hypotenuse, and this is x, then what is our hypotenuse? Well, first of all, if this is x, then what's this? Remember, hold on. Sides opposite congruent angles are congruent. So these angles are congruent, therefore, if this is x, then this is the same thing, it's the same length. So this is x. So if these angles are congruent, then these sides are congruent. Joe? Okay.
Is that 45 at the top? Yeah.
This is 45, sorry, it's bad 5. So if this is x and this is x, because sides opposite congruent angles are congruent. Please work on that. Okay, I'll help you with that in a few minutes, okay? Stop. Do your packet. I'm trying to. Okay.
So why do you use that thing that's like x?
Okay, so that's what I'm getting to. Good question. So when we go from a leg to the hypotenuse with the 45, 45, 90, multiply it by the square root of 2. So if this is x, and this is x, and this is x, square root of 2. Did I lose you guys?
Just a bit.
Okay, it's okay. We're going to get this. We're going to review it, and we're going to get it.
Where'd you get? Oh, are you making a
Where do you mean?
Where'd you get
Oh, I'm going to make another triangle, yeah. It's just kind of the way I've got it organized. So this is why I've been torturing you guys with square roots for like 3 weeks, because I wanted you to understand those before we get into these. Our next special right triangle. If one angle's 30, one angle's 60, and one angle's 90, which one is going to be the 30 one? And remember, the smaller the side, the smaller the angle opposite the side. So it's going to be this one, right? Okay. And this is going to be our right angle, and this is going to be 60. The way these work, if our smallest leg is x, that means our bigger leg is going to be what? X square root of 3. Okay? So that means the bigger leg is the square root of 3 times larger than the smallest leg. And the hypotenuse is twice as long as the smallest leg. And this is always true with the 30, 60, 90. I don't care if it's this small or if it's this big.
I know tons of ways.
These relationships always exist with 30, 60, 90s. It doesn't matter how small or big it is. If the angles are 30, 60, 90, then this is always true with these triangles. Because it's just the rule. It's the way these work. It's just always the case with these triangles. So let's actually do it with actual numbers. Okay, I know you're a little confused. It's fine. We'll get this. Let's get rid of these. Reyes, what number are you on?
3.
All right, if you keep talking, I'm going to send you to Joe's to finish.
Can I have, where's that at?
That's great.
What?
Where's that at?
Where's what? No, that's not for you, Lord.
Oh.
That's for them. Okay, so what kind of special right triangle is this? It's a 45, 45, 90, isn't it? Okay, there are only 2 special right triangles that we have to know. Oh, and I just got an idea. If someone wants extra credit, if you make me a poster with this for 45, 45, 90, and 30, 60, 90, then I'll give you 10 points. Destiny, did you hear that? Okay, Jose? Which one do you want? Jose and Carmen, you want this one? Okay, and Destiny, you want to do this one?
Yes.
Okay. Sorry I was picky for posters, but you're good at them, so. So where was I? Okay, so if this is 2, then what's this?
2.
2. And what is this?
2 times, right?
2,
Right.
2 square root of 2, or 2 times the square root of 2, they're the same thing. This just means 2 times square root of 2. All right, so let's go the other way now. So if this is, let's say this is 3. Now to go from here to here, we multiply by square root of 2, right?
So 2 square root of 2.
But now we're going from here to here. Ebony. So what's the opposite of multiplication? Division. So to go from here to here, we multiply by the square root of 2. Now we're going from here to here, so we divide by the square root of 2. So 3 divided by square root of 2. But what is that rule about radicals in the denominator? Can you keep them there?
No.
No, it's a definite no-no. So don't keep it there. So what do we want to do to it to get rid of that square root? We practiced this a little bit last week and a little bit the week before. So we want to multiply. Huh? Oh, I know what you're thinking of. No. I got you confused. That's with the negative exponent when you switch it. So multiply the top and bottom by square root of 2. So what's square root of 2 times square root of 2?
4.
Square root of 4, which is equal to 2. So square root of 2 times square root of 2 is 2. What's the square root of 3 trillion times the square root of 3 trillion?
1.
3 trillion. You're thinking of something to the 0 power. What's the square root of 5,605 times the square root of 5,605? 5,605. So any square root times itself is that number without the square root. Okay. So what I do here is multiply the top and bottom by square root of 2. Square root of 2 times square root of 2.
4.
Square root of 4, which is equal to
4.
2. Yeah. So now we've got 2 on the bottom. And what do we have on the top?
3 square root of 2.
And we just found our answer. That's our solution. You can just leave it like this. So if this is 3 square root of 2 over 2, then what's this?
3 square root of 2 over 2.
Yes, 3 square root of 2 over 2. Does that make sense? Guys, I want to do the 30, 60, 90 tomorrow. I'm sure you're excited. But I want to practice this and go around and give you all individual attention. And I'm going to upload this to YouTube since no one's here, sorry, to My Big Campus since no one's here today because of the snow. And I will send them to the computer lab to watch it tomorrow if they don't.
That's crazy.
If they come tomorrow.
It's true.
What?
Yes, of course.